Hi, my name is Faisal Hafeez. That is my email. My office hours are to be announced. Today I will be teaching you about limiting reagents. So without me telling you anything, what do we think a limiting reagent is?
The limiting amount of starting material.
Limiting amount of starting material. Okay. I'm looking for more.
Something that stops the reaction.
Something that stops the reaction. Okay, good. So what's a real world example? Say my car. What's the limiting reactant? My gasoline or oxygen in the air?
Yeah.
My gasoline, obviously, because that's the limited. So in a chemical reaction, the limiting reagent is the one that runs out first. So let's do an example. Say we have this equation. Okay, so what are my reagents in this equation?
Magnesium oxide,
Exactly.
hydrochloric
It's
acid.
on the left side of the equation. So the first thing you want to do to see what's the limiting reagent is you want to balance the equation. That tells you how much of what is being used up. So this is balanced. No?
No.
Okay. The really big one, so I'll balance it for us. So what's being used faster in this case? Hydrochloric acid, yes. For 1 mole of magnesium oxide, we're using 4 moles of hydrochloric acid. So, say we have 0.86 moles of magnesium oxide. And one second. 48.2 grams of hydrochloric acid. Which one's going to run out first? How do we know?
Look at moles.
Convert it to the same units, which in this case is moles. So how do we convert this to moles? Which one's right here? And let's see, I'll give you 36.46 grams per mole. That look okay? Can someone calculate that for me? All right, so we have 1 moles of HCl and magnesium oxide. So that means the magnesium oxide is a limiting reagent, right? Because we have more HCl? No, obviously not, because we're using 4 times more HCl and magnesium oxide, so we still have calculations to do. So what's the next step? What do we think we want to do to figure out which one's going to run out first?
Divide HCl by 4.
What's that?
Divide, I'm a mole of HCl by 4.
Divide by 4. No, not exactly. Let's see how much moles of HCl we'll use if we have 0.86 moles of magnesium oxide being used. So So for 1 mole, in napkin, I forgot all that. So for 1 mole of MnO2, how much HCl?
4.
So this will tell us how many moles of HCl we're using. Anyone want to calculate that?
3.44.
3 point what?
4.
Okay, so this is how much HCl we're going to use. Is this greater or less than this?
Greater.
It's greater. So therefore, we have less HCl than what we need to use 0.86 moles of MnO2. So what's our limiting reactant in this case?
HCl.
HCl, exactly. Okay, and then the question also wants to know, given our limited reactant, how much chlorine are we going to produce? Cl2. So what are we going to use? Are we going to use 1.32 or 0.86?
1.32.
Okay. All right, and what goes here?
4 HCl.
It's 1 mole chlorine gas. And 1 mole contrast.
0.3.
0.33. So why are limiting reactants important?
If you want to plant something.
Yeah, if you want to plant anything, you have to know exactly how much you need and what's going to run out first. So in this case, it's good to know that HCl is going to run out first. Okay, good job. Let's see. Do we know what actual and theoretical yield are?
I know what an actual yield is.
What is an actual yield?
So it's how much product you get from an experiment.
How much product you get from an experiment? And what's the theoretical yield?
If you convert all of your moles from one reaction all the way to your product, you have equal amount of moles.
So it's what you're calculating is what you're saying.
Exactly.
Not to put words in your mouth, but yeah. Okay, so what's typically the greater? If you go buy a car and it's telling you you get 35 miles per gallon and you go drive it, are you going to get 35 miles per gallon? Or are you going to get more or less? Less, right.
But what if you go downhill?
What's that?
I said, what if you go downhill?
What if you go downhill? That's a really big hill you're going down.
And if you're just cruising on the interstate,
Yeah?
you get more.
You know, in a Prius, you actually get less on the interstate.
Except it's Prius.
It's Prius. So why is actual yield less than the theoretical yield? Thermodynamics, something like that, exactly. Any other guesses or explanations?
Reaction.
Didn't finish.
Nothing is perfect, exactly.
Mhm.
Like, you burn something, does it always burn completely every time? No, there's always something left over, like charcoal. Charcoal is an incomplete combustion. So in real life, get less than what we calculated.
All right, yeah, we can stop there.
Cool.